Greetings! In the previous installment of this series, I planned the RF path for everything, and of course I tried it. I planned the power distribution. I also planned on sequencing, and now I have everything I need to install the gear inside the rear of the dish. Now, the first thing I had to do was to mark the locations for the different modules of my system and think about coaxial cable routing between the modules. So I'll cover this part, RF assembly, later, but I need to start with power distribution at this point. And I thought I'd shoot a video to show you where I am with this before there are too many modules and we don't understand what's happening. So everything starts with the plus 12 that comes into this fuse. I can show you. I don't know if it's going to be visible or not. There we go. There's a fuse right under the PCB here, and this is where the 12 volt is going to come in. And also there's a ground lug here. This is going to be where the ground for the battery connects. And then from that 12 volt I installed a terminal strip underneath. If you look here, right here, there's a terminal strip of 3 positions for the plus 12 and 3 positions for the ground. So this is where the distribution of the 12 volt starts, right here under the sequencer PCB. And because I was going to run out of space, I decided to stack up the sequencer board over the 12 volt distribution. 12 volt distribution, once it's done, we shouldn't have to touch it at all. And then we have access to the fuse to replace it from here. We don't need to unscrew the board. But everything that connects underneath is covered already, and everything else is going to leave these terminal strips and go to all the modules everywhere. In doing so, 12 volt distribution, I also took care of everything that's going to go to switching supplies. And here's what the plan is. The switching supplies will be in an opposite compartment. This normally has the dish that sits here and faces toward the camera. So by removing the dish, we have access to this compartment here. The dish comes really close to the bottom of this compartment in the middle, here in the center. But as we go to the sides, the dish surface goes up, and this buys us, I'd say, 10 centimeters of room. And what I've decided to do is to segregate the switching supplies, there are 2 of them, to this compartment, isolated from the other side, which will be analog regulation and the RF stuff, and use feed-through capacitors to bring the 12 volts in and then bring the 10 volt 0.5 out. And then same thing for the 5 volts. I come in with plus 5 through a feed-through capacitor, convert to minus 5, and then go back out. So you can clearly see that on both supplies, the plus 10.5 and the minus 5, we have some LC filtering, because this being switching supplies, this too, is going to spill a lot of trash on the rails, plus 10.5 and minus 5, and I don't want that. And then I do not want anything going back to the plus 5 and back to the plus 12. So filtering on the input to the 10.5 switching supply and filtering on the output. These are LC filters with bulk capacitance added as well, and you can see there are small capacitors here. So 1 microfarad, 0.1 microfarad, and so on. Those I built by hand on PCB surface. These are common mode chokes that I'm using as simple inductors. They're, if I'm not mistaken, they're 120 microhenry. And then they can take several amps. So that's perfect for this thing, which is going to supply 2.3 amps. So that's good enough. So even bulk capacitance on the input and output as well. This switching supply is available for about $8 and $9 on AliExpress and other online sites. and it's a buck boost, so it does both buck, so bringing down the voltage to a regulated voltage, or bringing up. If the input voltage is lower than the output voltage, it will do it. It will work fine. If the input voltage is higher than the output voltage, it will also work, and it transitions very well between being too low or too high compared to the output voltage. So that's what we call a buck boost converter. This one, I have tons of these. These are PT5022 minus 5 volt version. They're like 3 legs, like a TO220 regulator, but they're actually switching supply. And I've also added some LC filtering on the input and on the output. So I've added as much filtering as I could. And I think it's going to be all right because I did measure a lot of reduction with these filters and with these as well on the amount of switching noise produced. So hopefully this will be good enough. I think it is. These two supplies are used on the power amplifier, as you know, -5 and +10.5. Everything through feed-through capacitors. Now let's go back to the other side. So you can see the feed-through capacitors here, and I will connect the power amplifier to these two feed-through capacitors. And then the other signals are really from here, like controlling the 10.5 volt supply. We use soft switching. There's an input on that board, the blue board you just saw with the big toroid transformer. There's an enable input. So by using a low current signal, we can switch off the supply, which we do in receive, of course. But the -5 volts stays always on. It draws almost nothing anyway. So this will always stay on, and it's the +10.5 that gets switched. You saw that thing on the block diagram for the power distribution. So as you can see, I've marked and threaded all these holes, the ones that are marked in red. They're threaded 440 screws. So I can use 440 screws for screwing down all the modules. And I've also screwed down the 8 volt regulator down to the plate, because this guy is going to provide up to 500 or 600 milliamps of current, and that's a lot. So 12 volt in, 8 out, so that's a lot of power to dissipate, and so that's why I screwed it down to the bottom, and it'll be a good heatsink. The +5 is not solicited enough. No heatsink will be required. And then what to mention is the other thing that's getting 12 volts directly is the OCXO module. There's a built-in 5 volt regulator. There's no point in using +8 volt and, you know, just overload the +8 rail even more. In any case, it's no more efficient. So let's send 12 volt directly to this module, and then there's an internal 5 volt regulator, and everything is going to be great. And it's always on, so no need to switch. The other modules will be either always on the +8 or switch in TX and RX, receive transmit. So there you have it. That's where I am right now. So next step is to screw down the modules and wire them with the right 8 volts, whether it's transmit or receive or constant. So it's just going slowly but surely. Things are progressing. So next time you're going to see everything assembled. I'm pretty sure I'll be finished next time I shoot the video. Until then, 7-3.